Okay, so now as we study all the different forms of linear equations, we find that there's really like three different cases, okay, that we have seen. One case is where we are given 2 points, okay, so we are given 2 points that are in the line, all right? All right, so x1 and y1 and x2, y2, so these are 2 points in the line. So that would be one case. The other case that we have seen is where we are given 1 point, okay, x1, y1, all right, and then we are being told what the slope is, okay, what m is the slope. The third case that we have seen is where we are given the intercepts, okay? So we are given the y-intercepts, so 0, okay, and y1, all right? And we are given also the x-intercept, so x2 and 0, okay? So that is going to be another case where we see the different types of data. This third case is more useful when we are seeing kind of limits, all right? So let's suppose that I have two quantities of something, okay? And so I have quantities of x and quantities of y, and I have kind of a maximum of y. So the maximum of y is going to be there, my y1, okay, my y-intercept. And then I can have several mixes of x and y up to the maximum of x, okay? So if I have here x2, all right? And so that is going to basically give me that my limit, okay, of how I can mix these two values is going to be given by this line. If I want to maximize the number of things, the number of combinations of x's and y's, is going to be delimited by this way, all right? This is what is called a constraint, because I cannot go above this line, okay? So this is a no-no, okay? But I can also have mixes that are less, okay? So this is all right, okay? This is yes, all right? So this is yes. If I want to go to the limit of the constraint, that would be any of the values on the line. But that is the different cases of that. We have seen that when we are given 2 points, we can find the slope, all right? So we find the slope y1 minus y2, that is going to give us the delta, okay, the delta y, all right, the delta y, all right, divided x1 minus x2, okay, x2, all right? So, and that is going to give us the delta x, that is by definition the slope, all right? So that is by definition m, the slope. So when we have the 2 points, you can find the slope really easily, all right? In this case, we have already the slope, so we have 1 point. We can also then from here figure out the different forms of the lines and so on. So let's move on now and look at the different forms of linear equations that we have, okay? So let's see, we are going to see that the first one is the slope-intercept form of equation, okay? So in the slope-intercept form, we have that the formula for that is y equals mx plus b, okay? And so we know that in here we have the slope, okay? So this is going to be the slope, all right? So we can see that if we can figure the slope, or we are given the slope, we can easily find the slope and get this equation going. And then this value of b is going to be the y-intercept, okay? The y-intercept, all right? So then if we are going to graph this, b is going to be there where x is 0, okay? So that is going to be the y-intercept. And then if the slope is positive, we know that the line is going to have an upward slope. And if the slope is negative, then the line is going to go down, okay? And so we can actually see the slope. Oops, sorry, let's see if we can do this, okay, let's see, there we go, there, all right, and so in here we can actually see, oops, sometimes I'm up. Okay, let's see. We have the slope is negative, all right? And then the slope is going to be negative or positive. They are from the point B of the intercept. So that formula, the slope intercept. Let's take a look at the second one, the point slope. The point slope formula is actually very useful when we have here the point and the slope, all right? So the formula for that is going to be y equal minus y1, okay? Y1, the point that we are given, is going to equal the slope times x minus x1, all right? Another way of looking at this formula is actually by saying, oh, okay, so we can actually write it minus y1, y minus y1 over x minus x1 equals m. Okay. And that certainly makes sense because, any of the values of y minus the value of y1 is going to be our delta y. Okay. And any of the values of x minus the value of x1 is going to be our delta x. Okay. And by definition, delta y over delta x is m. So that is, the easy part there about this formula. So here in this interpretation of the formula, we have that we can find a point. Okay, so that would be our x1, y1, and then again the slope is going to determine whether the line goes down or whether it goes up or however we want to put it. Okay. So that is the point slope form of linear equations. The next one that we are going to consider is the standard form. The standard form is a capital A x plus capital B y equals capital C. And the reason why we use capital letters here for the standard form is because these A, B, and C do not really necessarily represent anything in the line, okay? All right. But this form, this standard form, is actually quite useful for solving systems of equations. We are going to see that this form becomes very useful for that. It also is actually very nice for solving finding the intercepts of the line, because if we want to find the y-intercept, we are going to assume that x equals 0, and so this whole term goes away, and so we are going to end up that by equals c, okay? And so the y-intercept is going to be c over b, okay? And so wherever we find that point, that is going to be c over b is going to be our y-intercept. If we assume now we want to find the x-intercept, then we assume that y is going to be 0, and then this whole term goes away. And so we end up that ax is going to equal c, and x is going to be c divided by a. All right. And so that is going to give us here the point, okay, of the x-intercept. So c over a. Of course, that it can be in the negative quadrant, however we want to do it, it doesn't matter, of course. All right. And then we will draw the line where as we find the two intercepts, and that was going to give us then the line for that. All right. So that is the standard form, a very useful form indeed. There's a fourth form that is not talked much about, but I find it also that is very useful. And it's basically what we call the slope x-intercept. Okay. So This one is the slope intercept where we have the y-intercept, but in this form of the equation, we have that is y equals m parenthesis x minus, and I'm going to put another parenthesis a. Okay, oops, sorry, let's do this again. Okay, minus oh, there we go. Minus a, okay, lowercase a. All right. So this lowercase a is not the uppercase a. This is the x-intercept. And this is actually a very useful formula in order to manipulate my lines whenever I know what the x-intercept needs to be. Okay, so if the x-intercept is positive, then the formula is going to be x minus a, and it's going to be somewhere over here, on the positive quadrant, okay? Now, if I want the line to move on to the negative quadrant, so we have a minus a negative a, then usually the form of this formula is going to be y equals mx plus a, all right? You need to remember that the standard form actually is minus, okay? So whenever a is negative, we know we are going to have negative times negative is positive, and so that is what you are going to see, okay? So that it corresponds basically to this line, okay, and then this other one corresponds to this point here on the positive side of the intercept. And of course, the slope is going to be, if the slope is positive, we are going to have a positive slope. If the slope is negative, we are going to have a negative slope, wherever that may be. So those are all the different forms of linear equations. And these are the main three ways that the data is presented. We either are given 2 points, or we are given 1 point on the slope, or we are given the y and the x intercepts in order to find the limits of the constraint for my x and y axis. All right. So I hope that this is useful for you. Thank you.